So I've drawn two simple ideal pendulums here. Both consist of a massless string of length L, which is attached to a pivot at the top, and we set these in motion from an angle of alpha. If the only difference between these two pendulums is the difference in mass, which of these pendulums do you think will swing back and forth the fastest? So this is a bit of a trick question, because so long as the string is the same length with both pendulums, they're going to swing at the same rate. And this can be proven by this formula here. So we got T, which is the period for a single oscillation. So the time it takes for the pendulum to swing from left to right back to left again is equal to 2 pi multiplied by the square root of L, which is the length of the pendulum, divided by the acceleration due to gravity, or the gravitational acceleration. And the length here of the pendulum extends from the pivot to the center of mass of the bob, or the mass at the end of the pendulum. Now, where in this formula do you see a term for mass? So we could have a small mass or a large mass at the end of our pendulum here, but the time it takes for the pendulum to swing one oscillation will not change so long as the length of the string and the acceleration due to gravity doesn't change. So what about this angle alpha here? Say if we release one of these pendulums at a smaller angle and one of these pendulums at a larger angle, would this change the frequency or the time it takes for these pendulums to oscillate back and forth? And again, the pendulums are the same length. So again, looking back at the formula, we don't have a term for the angle either. So both these pendulums will oscillate at the same rate despite their angle of release. So given this information, find me the period of this oscillator with a mass of 5.8 kilograms, a string length of 1.2 meters, and an angle of release of 15 degrees. And the acceleration due to gravity is 9.8 meters per second squared. So I've given you more information than you need here. We can ignore the angle and we can ignore the mass. All we're interested in is the gravitational acceleration and the length of the string. So the formula again is the period of the pendulum, so the time it takes for one complete swing, is equal to 2 pi multiplied by the square root of the length of the pendulum divided by the gravitational acceleration. After plugging in these numbers, we get a period of 2.2 seconds to two significant figures. Now, what do you think would happen if we doubled the length of the string? Do you think the pendulum would swing faster, or do you think it will swing slower? So if we have a look back at our formula, the term for the length of the pendulum is in the top part of the fraction. If we have any fraction and we double the value in the top of the fraction, we double its value. So if we double the length of the pendulum, this will increase the amount of time it takes for the pendulum to swing back and forth.